Hey, welcome to a new video. My name is Jack Jusko. I am a University of Michigan computer science student who's taking a gap year due to coronavirus. In this video, I'm going to be talking to you about HTTP, what it is, and how it is used for web application communication. HTTP stands for Hypertext Transfer Protocol. It's used for the vast majority of web communications. I'd say it is by far and away the number one way for a client and a server to communicate when building a web application, followed second by maybe WebSockets. Yeah, it is a request response model between the client and the server. So the way this is set up is, say here's your client, which is your browser, and there is a server, which is somebody's website. Your client is making a request to the server for some bit of information, and the server is responding to that request um, and sending a designated message back. Um, these requests have a couple different methods or designators for what the request is trying to do. The most common are get, post, put, and delete. But by far and away, get and post are the most common and the most frequently used request types, request directives. So contents of a request include the URL, which is realistically an IP address with a port attached to it, headers, and in some but not all cases, a body. So URL IP/port is the IP address. It also works with a domain name, and then the port that it is going to. HTTP servers have a default port that requests know they're running on. So when you are making an HTTP request to your browser, so you're going to Amazon.com, your browser is making an HTTP request to HTTP Amazon's URL, and then this colon signifies a port 80. You can't see this port 80 bit because that is what the default port is, so that is what public web servers run on. Also contains headers, which are basically preliminary bits of information about the request. This can include things such as the content length, of whatever request you're making, say who is calling this request, what is powering the request, etc. What cookies are in the request. Cookies may be something that a lot of you are familiar with. So any preliminary data that the server needs to respond. And then the body. This is not in every request. Say, for instance, if I'm making a GET request to Amazon.com up here, I have no need for a body because I don't have any data to tell the server that I'm uploading. But say I'm making a post request, which common example of this would be, say I'm on Imgur or some other file sharing website, and I am uploading a file or adding a new piece of text to a blog or etc. This would be a post request because you are posting new data, and then the body would be whatever data you're trying to upload. Now, not the cleanest way to delete that. That is, in essence, what the request is made up of. Now, the response to the server consists of status code, headers, and a body. The body is much more frequently used in response requests, regardless of what you're doing. Say if you're making a request to Amazon.com, their body in this response request would be all the HTML, all the text that's making up the web page that you're trying to view. Headers, the exact same thing, preliminary data for the response to give some preliminary info about the response. And then a status code is to indicate to a browser if this request is successful, if it hasn't gone through correctly. And the server, the client server, the HTTP server that the client is making a request to, can indicate if something went wrong, what went wrong, as well as a variety of other things. So commonly, the response code starts with 200 just means okay. The request has gone through successfully. I believe 201 off the top of my head is created, which would be for a post request for uploading something new. Commonly, failure codes start off with 4, so I think 400 is bad request. And I know 404. I'm sure you've all heard of 404. 404 not found. Resource not found. So that's the essence of how an HTTP request and response works. You probably make a couple hundred of these a day, even if you don't know it. Whenever you navigate to a new URL, you click a new link. You click any button that does virtually anything in your browser on any website you're on. That browser is making a new HTTP request to some location, as well as even when you go and type in the URL, that is making a GET request to the URL that you've just typed in. The last thing I want to add is security. I'm sure you've all heard of HTTP. HTTPS is probably equally as common. And HTTPS is a more secure overlay extension of Hypertext Transfer Protocol. It stands for HTTP over SSL. The way that this works is that the body of the request you're making and the headers, as in pretty much all relevant content apart from the destination, are encrypted and transmit, so that somebody who's, say, spying on your internet connection cannot read where you're sending a message to, like what message you're sending, as well as what the server is sending back. Though they can still read the destination that you're trying to access. This is done through RSA certificates, which is a type of encryption, which is two-way. The server has a certificate which is issued by a certificate authority. The function of a certificate is basically to verify and to actually create this encryption. The certificate contains the key used for encryption to encrypt data, as well as who issued it. Certificate authorities are used so that people can't just issue their own keys for untrustworthy websites. There's a third-party identifier kind of alleging that whatever server you're contacting, if it has a valid HTTPS certificate from this authority, then it's identified this website as someone they've issued a certificate to, and the website is what they say it is. Certificate authorities used to charge money, so SSL was less frequent, say, a decade ago than it is now. Within the last 4 or 5 years, I'd like to say, there's been a way of getting free SSL certificates through Let's Encrypt. And I'd like to say that now maybe more than 70% of internet traffic is powered by HTTPS, HTTP over SSL. That's the end of the video today. Thank you for watching. If you enjoyed this comment, hit subscribe, hit the like button, click the bell to receive new video notifications. I'm producing these on a fairly regular basis. If you didn't like this as much, but you have some other content you'd like to see, feel free to drop a comment below, and I'll read it, I'll respond to you, and I'll consider incorporating it into a future video. Signing off.